Hello students, welcome back. Let's take up the next question, which is a sample paper question. This question carries 3 marks. The question is, Mona was doing an experiment with magnetic compass and a straight current carrying wire. She observed that as she moved the compass away from the current carrying wire, the deflection of the compass needle reduced. First question is, explain why the deflection of the compass needle reduced as Mona moved the compass needle from the current carrying wire. B. Mention one thing that could have changed in the circuit of the wire that could increase the deflection of the needle. The third question is, explain with reason what will be the direction of the magnetic field associated with the wire for the case described by the above figure. So here we have a plane in which there is a current carrying wire which passes through this plane, and here we have a battery, and when the battery is switched on, the current starts flowing in this wire and there is a compass needle which is placed. Now Mona had placed a compass needle somewhere near the wire, but as she moved the compass needle away from the wire, the deflection of the compass needle reduced. So using these observations, we have to answer these questions. So let's answer them one by one. Now the deflection of this compass needle which is observed is due to the magnetic field generated by this current carrying wire. The magnetic field strength decreases with the distance from the wire, which reduces the deflection of the compass needle. That is, when this compass needle was placed nearer, the deflection was faster. But when the compass needle was moved away from this current carrying wire, the deflection in this compass needle reduced. So thus we see that the deflection of the compass needle is inversely proportional to the distance from the current carrying wire. That is, the nearer the compass needle is to the current carrying wire, the greater will be the deflection, and as the compass needle is moved away, the deflection in the compass needle reduces. So this is the reason for the first bit. The second bit is, mention one thing that could have changed in the circuit of the wire that could increase the deflection of the needle. Now in another way she could have increased the deflection at this point was by increasing the amount of current flowing in this wire. An increased current in this wire would have resulted in the increase in the strength of the magnetic field, which would have increased the deflection of this compass needle. So the second reason is, by increasing the current, i.e. the deflection of the needle could have been increased. The third, explain with reason what will be the direction of magnetic field associated with the wire for the case described above. The direction of the magnetic field associated with this can be determined using the right hand thumb rule. That is, if the current flows in the direction of the thumb of our right hand, then the curl of the fingers will represent the direction of magnetic field lines around the wire. Now in this given figure, the current flows downwards. So since the current flows downward, you can see the fingers are curling in this way. That is, the magnetic field direction is clockwise. So the magnetic field will circulate in a clockwise direction around the wire. That is like this way. So this is the answer to the third bit. So let's analyze the answers now. The first question is, explain why the deflection of the compass needle reduced as Mona moved away the compass needle from the current carrying wire. The answer is, the magnetic field produced by a straight current carrying wire is inversely proportional to the distance from the wire. As Mona moved the compass away from the wire, the distance between the compass needle and the current carrying wire increased, and thus the strength of the magnetic field acting on it decreased. A weaker magnetic field resulted in a smaller deflection of the needle. So this should be your first answer. The second question is, mention one thing that could have changed in the circuit of the wire that could increase the deflection of the needle. There is another way by which we can increase the magnetic field strength, and that is by increasing the amount of current. The answer to this question should be, the magnetic field strength is directly proportional to the amount of current flowing in the wire. So Mona could increase the current in the circuit to increase the field strength and thus observe a greater deflection of the compass needle. So increasing the amount of current will result in an increased value of magnetic field strength and a greater deflection in the compass needle. The third question is, explain with reason what will be the direction of the magnetic field associated with the wire for the case described in the above figure. Now You can see here the battery, this is the positive terminal and this is the negative terminal. So current flows from positive to negative. So we see the current direction is from top to bottom, and on comparing it with the right hand thumb rule, we see that the fingers are curling in the clockwise direction. So the magnetic field will be in the clockwise direction. So the answer should be, the battery suggests that the current is going from top of the plane to the bottom of the plane. So using the thumb rule, we can say that the magnetic field will be in the clockwise direction. So these are the answers to this question. So with that, we come to the end of this video. If you found this video helpful, please do like this video, share it with your friends and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.